All right, AP Chemistry, we're on to the last question in the winter packet. Now remember, part of the winter packet is also to do Unit 3 from the Princeton Guide, all of the multiple choice, and the first 3 free response. And I will be posting those answers at a later time. Okay, so let's finish up this part of the assignment. So perform the heating curve calculation from -10 to 110 degrees centigrade for 2.5 moles of H2O. All right, so in this question, you're given an amount of H2O in moles. Down here, here's the conversion. 2.5 moles is equal to 45.5 grams, because for some parts of this problem, you need to have the quantity in moles, and other parts of the problem you have to have it in grams. Normally a problem like this, they wouldn't give you both. You would be expected to use a molar mass conversion for water, 18.02 grams per mole, to convert between these two, but you are going to need both of these figures. Okay, so let's just kind of take an overview of this problem. So what's happening is you have ice down here. You're below 0 degrees centigrade and you have ice. So here, on the x-axis, you have heat, and on the y-axis, you have the temperature increase. All right, so initially ice, you're going to put in heat and start to heat it up so that it's still ice, but it's getting warmer and warmer. It's going from -10 up to 0. Then when the ice starts to melt, the temperature stays the same. Okay, some students find that hard to believe, but it is true that the temperature stays the same, which is at 0 degrees while the ice is melting. Okay. Then once it becomes totally melted at 0 degrees, it immediately starts, as you add heat, to increase its temperature, going up here from 0 to 100 degrees. So it'll eventually arrive at this point. Then the water starts to have enough energy to boil away. So little by little it'll start to boil away. So while it's boiling, the water stays at 100 degrees. Water in its liquid form can never be greater than 100 degrees. Once a molecule reaches a greater temperature than that, then it floats away. It basically boils away. Now it gets to right here. All the water has boiled at 100 degrees. So now any additional heat will cause the steam, the vapor, to heat up. And it will go up to here, up to, in this case, 110 degrees is where we're going to stop. And it's for this, and this, and this. And I call this the slope formula. Okay. And then we have the formula. Now notice this one, by the way, uses mass. So that's where you're going to use the 45.5 grams. Okay, now the other formula is at Q. Again, both of them are for heat. How much heat it takes to make the ice melt. And that's going to be the number of moles. And notice there's no delta T here because there's no temperature change at these points right here. Okay, so it's the number of moles times the delta H. And this is for the flat parts. Okay, so this one right here and this one down here. Okay, all right. So we'll come down here and do the calculations down below. Now, what do you use for this slope? You have mass, 45.5. C. C is going to be the heat of the C of ice, the specific heat of ice. You'll notice that the specific heats for ice, water vapor, that should be lowercase, and that should be lowercase. Water and water vapor, all different. They're not the same. Depends on the state of matter what their specific heat is. All right, so let's go ahead and get started. So we're going to do this lower part right here. I'm going to come down here, and that's going to be, okay, so let's label what it is. From -10 degrees to 0 degrees. It's going up in temperature here. Okay, and so it's going to be Q equals the mass, and we have that up here, 45.5. That's always going to be the mass, times specific heat, C, and it's the specific heat for ice, this one right here. Same units though. And again, there was a correction that I never seem to get corrected. It's joules on the top and joules on the top. Joules per gram, and it's Kelvin. Now, if this point is not clear to you, a degree on the Kelvin scale is a degree on the centigrade scale. If it's a change in temperature, which this is, then it doesn't matter which scale you use. So I'm going to go ahead and change that to degrees centigrade because everything else is in centigrade. I'm going to change this also to joules and degrees centigrade. And I promise I'll get these corrections made for the next class or the next time you see this assignment. Okay, so it's 2.03 joules per gram degree centigrade. All right, and the delta T is going from -10 to 10. It's going upward, so that's a positive 10 degrees. Okay, and then another trick to this problem is that this formula is going to produce a unit of measure of joules, whereas this one is going to be in kilojoules. We usually express this in kilojoules, so that means this one, anything we get out of this formula, we need to convert to kilojoules. So we're going to come here, okay, and that'll give us our answer in kilojoules. And we get 0.92 kilojoules. Now we're going to go along the flat here. Okay, the ice is melting along here. Temperature doesn't increase, but because all of the heat goes into breaking apart the intermolecular forces holding the water molecules together. Those are dipole-dipole hydrogen bonds and LDF. So we're going to use this formula. So I'll write it like this: 0 to melting, 0 degrees centigrade. And now we have to deal with moles, and we said that that is going to be 2.5 moles. So 2.5 moles, 45.5 grams of water are the same. And now what we have to use is what's called the delta H of fusion. Fusion means to put something together, to stick something together. In this case, it's the opposite direction. If we're melting it, it's going to be a positive number. If we're freezing it from liquid to ice, it's going to be a negative number because heat is coming out. But the word fusion, so you use the same number, it's just an opposite sign. So that's called the delta H of fusion, and that is 6.07, and you notice it's in kilojoules, kilojoules per mole. And that's going to equal, the moles will cancel with moles. So now it's 2.5 times 6.07, and that's going to give you 15. I'm going to write it over here so these are all lining up right here. 15.1, and it's already in kilojoules, so we don't need to make the conversion. I'll take that away. Okay, so we're going to add these heats up at the end to determine how much heat it takes to go from the -10 up to the positive 110. All right, now we are going from 0 degrees to 100 degrees. So the water is liquid this entire time, but it's getting hotter and hotter. We go back to the slope formula, mc delta T. And now we have to get the specific heat of water, which we've used many times before. It's 4.18. That specific heat of liquid water. And the change in temperatures from 0 to 100. We're heating the water all the way up to the boiling point. And then we make our conversion from joules, because this is in joules, you can see that right there, to kilojoules. Okay, one thing I haven't been doing is canceling my units. So joules cancels with joules up here, centigrade cancels with centigrade there, grams cancels with and I wrote degree centigrade for this. I'm sure you caught that. I didn't. That's grams. That's a good thing I did that. You check your units. You make sure they cancel. That's one of the reasons you do it. Okay. With grams, anyway, we end up with kilojoules as our unit. Okay, and so I have 19.0 kilojoules for this one. I went back and canceled all my units, and I noticed the same mistake up here. I, for some reason, put degrees centigrade. It's actually grams. That's the mass. And so I corrected both of those. Okay, so everything is looking good now. All right, now we're ready to determine the heat that it takes to boil the water from liquid to steam. to make it into vapor. Okay, and there we use a different delta H of fusion. Or excuse me, delta H, it's delta H of vaporization. And it's this number, 40.67 kilojoules per mole. Notice how much greater the delta H of vaporization is than the delta H of fusion. All this heat is doing is taking frozen ice molecules and making them a little looser so they can flow around each other as a liquid. But this one has to take those liquid molecules and actually put so much energy into them that they break away from the liquid and float off into the atmosphere. So this is a lot more energy to go from liquid to vapor than to go from ice to liquid right there. Okay, so let's go ahead and do this. So we're going to use the flat equation here. And this is going to be from 100 to 100. And I should put vapor 100 degrees and then vapor. It's going to vapor 100 degrees. Liquid water cannot go above 100 degrees. Okay, so we have Q. Okay, and for this one we get 101.7 kilojoules. Okay, right there. Now we've got the last little piece to do here. You got to go from 100 degrees to 110 degrees, and that's a slope. And we have to use the specific heat of steam or of vapor. Okay, and that is right here, the C of water vapor, 1.84. And the change in temperature, we're going from 100 to 110, so that's 10 degrees. And then we need to make our conversion to kilojoules. Okay, and I didn't do my cancellation again here, so it's moles and moles cancel. You have kilojoules. Here, joules cancels with joules, grams with grams, and centigrade with, I should have put the C there, centigrade. So you end up with kilojoules as your unit. So we'll go ahead and do that calculation. And that gives us 0.84 kilojoules. So this is the amount of heat that went into taking that water from negative 10 degrees to 110 degrees. So now we add those up to get our final heat required to melt this specific amount of ice, 45 grams or 2.5 moles. Okay, so when we add all these numbers, we get the heat total, and that's going to equal 137.6 kilojoules. All right, again, that's the heat required to bring a certain amount of ice, 45 grams, 2.5 moles, from negative 10 up to 110. Requires that much heat energy put into the ice, or to the H2O, we'll say. All right, that takes care of this problem. I will do the Princeton problems on separate videos, and those will be upcoming. This concludes the packet that I created for the winter packet.